In this video we're going to look at the different type of algebraic fraction question that could come up in your Edexcel GCSE. Last time out we looked at ones where there was a single algebraic fraction, and when those came up we learnt to factorise and then to simplify. In these ones you can note the difference is that we have two fractions in the question, and on this example the operation in the middle is adding, but this would also apply if we were, for example, subtracting. So let's think about, before we start, how we add normal numeric fractions. So if I had, for example, 1/3 plus 1/4, there's a simple three-step method for this. Step 1, we need to find what's called a common denominator. And by that we mean create the denominators of both numbers into a value that's equal. So we currently have thirds and quarters, and I need to think about a number that both of those can become factors of. The easiest way to do this is to multiply them together. So I'm going to turn my thirds into twelfths, because 3 times 4 makes 12, and I'm going to turn my quarters into twelfths. Step 2 is to do the same to the numerators, the top numbers. So to have a look at this now, to turn my thirds into twelfths, I've multiplied by 4, so I'll do the same to the top, so that gives me 4 twelfths. And to do my quarters into twelfths, I multiplied by 3, so I'll do the same to the top, which leaves me 4 twelfths, which is an equivalent fraction to a third, plus 3 twelfths, which is an equivalent fraction to a quarter. And then I can do step 3, which is to add, in this example, but in another example it could be subtract, add the numerators only. So we end up in this example with 4 plus 3, which is 7, and we were talking about twelfths, so I have 7 twelfths. So let's use this example and follow it for the algebra question. Currently I have denominators which are different, so the first thing I'm going to do is I'm going to multiply them together. So I end up with, on the denominator of my common fraction in a minute, x plus 4 is the denominator for the left hand side, multiplied by x minus 4, which is the denominator on the right hand side. Now what we notice is for step 2 we need to do the same to the numerator. So because this side was multiplied by x minus 4, I'm going to need to multiply the top by x minus 4. So I'm going to have one lot of x minus 4. On the right hand side, because this denominator was multiplied by x plus 4, I'm going to also need to do this on the top as well. So I'm going to have 2 times, or 2 lots of, x plus 4. And don't forget, in the middle here we're adding these fractions together. So I now have what looks like quite a complex question, but I've done the tidying up in terms of the method for adding fractions together. So let's go through this then. One lot of x is 1x. One lot of negative 4 is negative 4. Then we have our plus sign here. 2 lots of x is 2x. 2 lots of 4 is 8. And then on the bottom I've got a quadratic expansion. X multiplied by x is x squared. X multiplied by minus 4 is minus 4x. 4 multiplied by x is plus 4x. And 4 multiplied by minus 4 is minus 16. So let's now tidy all of that up. So we have 1x, and we're going to add another 2 x's to it. Well, that gives us 3x. We have negative 4 add 8, so on our number line we're at minus 4 and we come up 8 places, so that'll give us plus 4. And on the denominator I have my x squared, I have minus 4x plus 4x, well that takes me to 0, so they cancel each other out, and I have my minus 16. So I end up with 3x plus 4 over x squared minus 16. Let's have a look at the second question on this sheet and see if we can follow the same method. Looks slightly easier because the denominators are numeric this time, but we'll follow with the same method. So step 1, we're going to multiply the denominators together. So we're going to do 4 times 3. So my denominator is going to be 4 times 3, which in a minute we'll find is 12. On the left I've multiplied by 3, so I'm going to need to times the numerator by 3 as well. So 3 lots of x plus 3. On the right I've multiplied the denominator by 4, so I'll also multiply the numerator by 4, so 4 lots of x take 5. And then just like we did on the other example, we can go through and see if we can expand this now. So 3 lots of x is 3x, 3 lots of 3 is 9. 4 lots of x is 4x. And 4 lots of negative 5 is negative 20. All over 4 times 3, which is 12. Let's tidy this up. So 3x goes with plus 4x to make 7x. And plus 9 subtract 20 is minus 11. All over our common denominator of 12. Now the final question is much trickier. And it's much trickier because it's equal to something, so we're going to have several extra steps to do, but let's start in the same way. So, step 1. I'm going to find a common denominator. Let's for a moment ignore this equals 4, so we'll just do it like we did the previous two questions. So I need to multiply the two denominators together. So x plus 2 multiplied by x subtract 1. On the top, because on the left-hand side I multiplied by x subtract 1, I'm going to multiply that on the numerator as well. So 7 lots of x subtract 1. Don't forget the plus sign here. And then on the right, because I multiplied by x plus 2, I'm going to do the same on the numerator as well. Let's expand all of that. So 7 multiplied by x is 7x. 7 multiplied by negative 1 is negative 7. 1 times x is 1x. And 1 times 2 is 2. And then on the denominator, we've got x times x, which is x squared, x times minus 1, which is minus 1x, 2 times x, which is positive 2x, and 2 times negative 1, which is negative 2. So let's tidy all of that up now. So we end up with 7x's plus another x is 8x, minus 7 plus 2 is minus 5, and then our denominator, x squared stays as it is, minus 1x plus 2x is plus an x, and our minus 2 stays on its own. So we followed the same steps so far like we did on the first two questions, but now we have to remember back on the original question, this is equal to 4. So we now have, if we move the question up here so we can carry this on, we now have a question where we're going to start by thinking about the idea of solving equations. And solving equations requires us to do the same thing to both sides. So the first thing I'm going to need to do with this question, if I just write it out again, 8x minus 5 all over x squared plus x minus 2 is equal to 4, is I'm going to want to try and get this all on one line so I can think about balancing it through. So the first thing I need to do is I need to get rid of this divide by x squared plus x minus 2. And we know in inverse operations to get rid of divide we're going to multiply. So on the left hand side I'm going to multiply by x squared plus x minus 2. So I also need to do the same on the right hand side as well. So multiplied by x squared plus x minus 2. So on the left hand side this cancels out this. So we're left with our 8x minus 5. And on the right hand side we end up with 4 multiplied by x squared plus x minus 2. So let's expand that bracket now. So therefore 8x minus 5 is equal to 4 lots of x squared, well that's 4x squared, 4 lots of x, that's 4x, and 4 lots of minus 2, that's minus 8. What we now recognise from our previous work is that to be able to solve a quadratic, and we know it's a quadratic because we've got a squared term in the question, we're going to need to rearrange all of this so it can equal 0. So we'll leave all this where it is because this side's already got the most terms on it, so we need to remove this. So we need to get rid of our 8x, so we're going to subtract 8x, and we need to get rid of our minus 5, so we're going to add 5. And we're going to have to do that to both sides. So we're going to subtract 8x, and we're going to add 5. So what we end up with there, if we do this now and follow this through, we end up with our 4x squared. 4x minus 8x takes us to minus 4x. Minus 8 plus 5, so we come up the number line 5 places, takes us to minus 3, and that's now equal to 0. And if you're wondering why they're now on opposite sides, we've just been able to turn them round because if this equals this, it doesn't matter that this equals this. So I've moved all this over here, and I've moved this over there just so it looks more common. Now, what I can do with a quadratic is I can factorise it to try and solve. If that doesn't work, then maybe I could use the formula, but I think I'm going to try and factorise this one first. Now it's a complex factorising where we have a term in front of the x squared, so we've got a coefficient here, so we're going to use the slightly more complicated method. So the first thing I'm going to do is the a term here, which is 4, multiplied by the c term, which is 3, so 4 3s are 12, and I need to think about all the pairs that can make that. So I've got 1 and 12, 2 and 6, 3 and 4, doesn't matter in which order you've written them, and then I need to look for a pair here that can somehow make my b term, which is 4. So it looks like that's going to be the 2 and the 6. So I'm now going to rewrite this. I'm ignoring the equals 0 just for a moment here. I'm going to rewrite this as 4x squared. Then I'm going to have 2x and 6x, and I've still got my minus 3. And I need to make these two terms make a negative 4 when they're added together. So that's going to mean that's plus and that's subtract. Then what I'm going to do is I'm going to split this down the middle into two terms, and I'm going to make this factorised in a linear way and this factorised in a linear way. So the biggest term that goes into this and this is 2x, and if I think about what I need here, that when I multiply it by 2x I get 4x squared, I know that's 2x, and if I think about what I need here, that when I multiply it by 2x I get 2x, well that's plus 1. Here the term that goes into this part and this part is negative 3. Something multiplied by negative 3 is negative 6x, well that's going to be 2x, and something here multiplied by negative 3 to give me negative 3, well that's 1. Little check in here, are our brackets the same? They are, so it's very likely that we're right. So my solution then is this part, which is 2x, combined with this part, which is negative 3, and then the 2x plus 1 forming my other one. And don't forget, even though that we've been concentrating on factorising at this stage, this is equal to 0 because this is what the quadratic that we're trying to solve. Now the final stage here is to think about how we can have these two terms when multiplied together equaling 0. So remember, and don't forget there's a times sign in here, so it's this multiplied by this is equal to 0. So the question you have to ask yourself here is, what do I do when I'm timesing two things together so that the outcome is 0? And you recognise that actually at least one of these terms is going to need to be 0 itself, because anything multiplied by 0 is 0. So I need to turn this bracket to give me a total of 0. So if I imagine something underneath my finger here, something subtract 3 is 0, well I'm going to have 3 under my finger because 3 subtract 3 is 0. So 2 x's are equal to 3, so that means x is going to have to be equal to 1.5, or if I think about this bracket here, underneath my finger again I've got something that when I add 1 to it I end up with 0, so that's going to have to be negative 1. So 2 x's are equal to negative 1, so x must be equal to negative 1/2. So my solutions to this question are x is equal to 1.5 or x is equal to negative 1/2, and it would make sense then to substitute them back into the original question and check.